Hello and welcome to section 2.3. Again, I'm testing out my microphone here, seeing if I can get the volume to pick up a little bit better on my computer. Here are the answers for 2.2. Okay, we're going to be working with deductive reasoning. So before we use inductive reasoning, and today we're going to use deductive reasoning. So inductive reasoning uses patterns and examples to come up with a conjecture. We're using facts, definitions, accepted properties, laws of logic to form a logical argument today. So it's going to be more concrete. So this is the law of detachment. I'm not going to spend too much time on this. Sorry about that beeping or buzzing noise. There's something with the frequency, so I'm playing with the volume here. So anyway, I'm not going to spend too much time on the law of detachment. It's just not that important for what we need in this course. What it says is if the hypothesis of a true conditional statement is true, then the conclusion is true. So here's my if-then part. This is the hypothesis. If the hypothesis is Mr. Drexler's running, and then the conclusion is he is happy, so after the then. So here's my hypothesis, and here's my conclusion. All right, so if the hypothesis is true, so Mr. Drexler is running a race. We'll say running a race. Okay, well then the only thing that we conclude is he is happy. And that's it. So that's the law of detachment. There's some problems in your book. I've actually cut those problems from the assignment just because I don't find them that beneficial for you guys. This one is more important. It's kind of like the transitive property. The transitive property is if A equals B and B equals C, then A equals C. This is very similar. Okay, if P then Q, if Q then R, so if P then Q. So here's an example of this. If it's snowing in Minnesota, then people drive slower. If people drive slower, then it takes longer to travel. So if it's snowing in Minnesota, then we can say it takes longer to travel. Basically, you cut out the middle part. So here, so if it's snowing in Minnesota, that's P. People drive slower, that's Q. So if people drive slower, that's Q. It takes longer to travel, that's R. And I'll do a couple more of these examples for you. Okay, so here's a couple more examples. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So here's my P. Then Jesse will be Rick's lab partner, that's Q. Notice how Q is the same, Q and Q. And then Rick will get an A in chemistry, that's R. So choose a different color so you can see this. All right, so what we're going to say is if Rick takes chemistry, this year, then Rick will get an A in chemistry. All right, if x squared is greater than 25, then x is greater than 20. If x is greater than 5, then x squared is greater than 25. Now this one's unique because it's kind of backwards. We need to switch these two around here. So it needs to go, if x is greater than 5, that's P, then x squared is greater than 25. X squared is greater than 25. That's the Q part, because the Q part is right here as well. So you gotta read it starting with this one first, then this one second. And then x squared is greater than 20. That's your R. Let me erase this part here. Now that we're done with that one. So this right here is my R. So if x is greater than 5, then x squared is greater than 25. And that's it. For the next one, if a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. So here's our P, here's our Q, here's our P, here's our R. So this one doesn't go, it goes P, Q, P, R. So this one's no, we can't use the law of syllogism to rewrite that. What conclusion can you make about the product of an even integer and any other integer? So product means to multiply. So an even integer, so 2 times any other integer, 2 times 3, 2 times 5, 2 times 4, 2 times -1. Okay, that's inductive reasoning. We're looking for a pattern here. So 6, 10, 8, -2. It's always even. Okay, so I looked for a pattern. I just did some sample problems. Okay, it's always even. Good. Deductive reasoning is a little more complicated. So to do this one here, the product of an even integer. So let 2n be an even integer. So this is kind of like a proof. And the reason why I know that 2n is an even integer is because it's divisible by 2, so it has to be even. And then we're going to say, let m be any other integer. Okay? The product, if I multiply 2n times m, must be even because 2nm is divisible by 2. So you're going to see questions like this in your homework. They're tricky for the first time you kind of do them, but give them a try, and they'll start to make sense. They're all kind of done the same way, but they are going to seem challenging for you when you first start these. So this sample problem right here is a good sample problem to have in your notes. And then we do this last problem here. Tell whether the statement is inductive or deductive. Explain your choice. The northern elephant seal requires more strokes to surface the deeper times. So this is just a trend, okay? It's not always true, because here, this seal right there, it took 380, and this one here it dove deeper, and it only took like 220. So this would be inductive reasoning. We're using general patterns and trends. And then part B, the northern elephant seal uses less strokes to surface from 60 versus 250. So 60 is right here, and then 250 is right here. So that would be factual. We have the data for that. So that would be using deductive reasoning. So facts versus trends is kind of what we're going for. And then here's the assignment for 2.3. Thank you guys for tuning in, and I'll see you for an extension on 2.3.